Hello, everyone. Let's continue with the part of the integument that involves the ancestral claw and the derived form of that referred to as a hoof. And hoof, we typically associate with ungulates. And you can see by looking at this picture here, the end of a cervid, the cervix digits here, what you see is that each one of the toes here that you see here has is completely enveloped by this modified claw. Okay. So that is, and that's, the whole thing is a package we call the hoof. And not more than that, the end of the whole end of the structure we refer to as the hoof. For example, this mammal right here, we wouldn't refer to each of these as separate hooves. The whole thing is a hoof. It's a hooved mammal. They are oftentimes called ungulates. Typically, they are herbivorous and they're large. They have long limbs. They are adapted for running. If you look at, if somebody who is familiar with horses, you know that the hoof is an extremely important and problematic part of owning a horse, especially if you're somebody who does a lot of riding. The hooves have to be near perfect. Flaws like a crack or uneven wear or uneven growth or infections can ruin everything and cost you thousands of dollars. And sometimes the horse might not ever recover. They're not easily repairable. The science of what farriers do, that's what you call the people who do hoof care, is very complex here. Here's a section through a hoof. Person's here is explaining all the different layers of that. But the point is here is that for a hoof and an ungulate, you have the entire ancestral claw. The hard part here is the surrounds the entire end of the disc. This is the last bone right here, or like your last segment right here. Look at that last segment of the foot of the limb is completely enveloped in hoof, hardened unguis with subunguis underneath it. That's a hoof. And that's the third digit. 1, 2, 3, all extended into a long structure. That's what we refer to them as ungulates. What can they do with these hooves? Well, these videos here I'm going to show you will show actually two keratinized hard structures that some mammals grow, and we'll show you what the function of the hoof is. Keep in mind that most ungulates are fast-moving, and they are, frequently in contact with hard ground, oftentimes rocky ground. You're a lot of weight on top of perched on a skinny leg. Big problem in horses. They have the ends of the legs very skinny, all that weight up on little skinny structures there. So if you look at this video here, these are cob. This is during mating. The way they mate is males gather on a lek, display, and sometimes fight, and females sort of mill around. Females will mate with the dominant males. Dominance is determined by these ritualized battles. So what you're seeing here is actually horn and horn structure, similar to antler structure. But I want you to look at the hooves, though. Look at those skinny legs. You have a heavy mammal and skinny legs, heavy, fast-moving mammal and skinny legs. So obviously, the hooves are tough. They're hard. They're protective. They dig in. They're on them all the time. And of course, they're going to continue wearing and out in the wild. But our horses, the domestic horses, don't move around so much. And oftentimes the environment is fairly soft, the substrate is soft, so they have to have their hooves trimmed. Otherwise, they get overgrown. Here's another, I'll save the next one here when we talk about horns and antlers. Oh, by the way, apparently moose also need hoof care in the cases where a moose is kept. And there they are. Because they're in a pen, they not moving around like they would in the wild, and so their hooves don't wear down. And they have to, you have to imagine that. It's hard enough working with a horse, they're docile. Imagine a moose, which are extremely dangerous. So the structure here, you can see here that there's a subunguus, and the inner layer is a subunguus. The outer layer is the unguus. What comes into contact with the ground is mostly unguus, and that's the hard part. It's going to grow faster than the subunguus, and it's going to need to be worn down faster as well. Otherwise, it'll become overgrown. And the way it grows, the relative rate at which it grows from the sides compared to the tip, will result in the tip being point. What you're seeing, how does it grow into a point? It has to do with the differential rate of growth on either the side compared to the front. And the point of growth is down here, the base of the subunguus. So here's a diagram. Nails, basically claws that are out of the way of the front of the digits and stay out of the way. Claws, which dig in, scrape. The whole point is to dig in and to be very sharp and pointing. And then hooves, which are a nice hard cap on the end of a foot. Digs in and is very tough, and also needs to have natural wear. So ungulates are very diverse. The hooves of everything you call an ungulate might not be all homologous, but they are all homologous with ancestral claws. Perissodactyla, the hooves of a Perissodactyla, and the hooves of an Artiodactyla, like a pig. I don't know that they're homologous. Honestly, they are in the same, apparently in the same group. Clade is sort of a sister taxa of ungulates. However, I don't know whether the common ancestor had a hoof-like structure. I'm not sure how well that fossilizes. Here's just another section showing how complicated, complex, and problematic horses' hooves are. Notice the sharpness here. So you find out if you ever get stepped on by a horse. That's another problem with being out, is you never wear sandals if you're out around horses. You always want to wear something on top to have some layer of fabric between you and that nail, because actually it's quite sharp. Not sharp like a claw, but sharp enough that it can cut you. Yeah, look at this, these 3 bone segments and the hard tissue surrounding the whole thing. So that is, those are hooves. Now let's take a look at the other hard structure on ungulates, which is horns, antlers, and similar projections. What's really interesting about these, many of these is that the function of them is not obvious in the sense that it's actually completely necessary for survival. So a hoof, you look at a hoof and you see the way an ungulate moves around in its environment, it's just obvious it has to have the hoof. But if you look at antlers and horns, it's oftentimes not obvious why they need them. They use them, right? But it's not, day-to-day survival doesn't seem that important. Oftentimes it's not. But it is something that we typically associate with ungulates, even though many ungulates don't have them. So there are different types of horns, antlers. There are, for example, the rhino horn, which is not a bone at all. It's not a bony growth. Epidermal cells. They're like hair-like, actually. We have the giraffes, which is a very unique type of horn. Very, very different from the cervidae, which are the moose, elk, and deer. And the Antilocapridae, and then the bovidae, which are the probably the most diverse in the structures of their horns. Here's the bovids here. Bovids are, if you've ever walked into those old-fashioned museums, the section museum where there's a bunch of heads on the walls, I think it's in the Harvard Museum. They have a separate section of the Harvard Museum there, sort of dedicated to the way museums used to be, which was, a lot of that was just somebody would go to Africa and come back with, kill big game and come back with the heads preserved. They'd mount them, do expert taxidermy, and you'd have heads on the walls. And that was kind of what museums did in a lot of the ways. That, of course, is not, museums now are really geared toward children, especially in education and outreach and conservation. But anyway, I think it's a Harvard Museum. They have a wall, and you walk in, there are all the heads. And any museum will have something like that, but that's not what you typically see when you walk in. But they are really fascinating. And the different species have different horn shapes. Usually, oftentimes, both sexes will have them. Male is oftentimes larger. You'll see why. But what's amazing about horns and antlers is its bony growth. So, we have two big forelimbs and two large legs. Think of the bones in your legs and arms. That's got to make up at least a quarter of your body mass total. Just the bones in those. They're heavy, and they really are thick, and fortunately not easy to break your long bones. But imagine growing a new one of those out of your head, because that's basically what you have with a horn or an antler. It's a bony growth. It's a bone that grows out of your frontal bone. That's amazing. Imagine a little bump on your frontal bone. Maybe some people even get them grafted on a horn. I've seen that before. If you have a little something underneath and it looks like horns. But imagine growing a bony growth, not just a bump. Some people have a little bump, anomalous bump somewhere. But imagine growing an entire bone. You talk about antlers and then losing it and regrowing it every year. That's pretty amazing. We'll see examples of this in lab. So what's in there? If you look at a section through a horn, you see in the case of a horn, horns, by the way, are typically not lost annually. And what you have is actually an extension of the skull. It's not, does it really count as frontal bone? I'm not sure, but it basically does. It's attached permanently. It grows out and forms a bony core with a keratin sheath. There's a sheath there. Somewhere around the house here, I have the sheath from the horn of my favorite goat when I was growing up in Missouri. She died. She got into Thanksgiving Day, we were away. She got into the chicken feed, ate too much of it. Her rumen bloated up and she died. What I have is not her whole horn, but I have the sheath of it. Somewhere around, found it for not too long ago. So that's what you see is the keratinized sheath. Underneath is the bone, and it is heavy. It takes a tremendous amount of energy to grow. Look at this. It's an extension of the frontal bone, in this case here, not always, with a keratinized sheath. Why grow something like that? Well, they are great examples. The best examples maybe of sexual selection. Sexual selection, natural selection is the same thing. Sexual selection is a form of natural selection, where you have a characteristic gives the individual a slight advantage over some alternative, not because of survival, day-to-day survival, but in terms of producing children, ultimately children, mate success. So, one of the best examples I know of is here. In the environment, this also is a good illustration of what the hoof, the function of the hoof. These mammals live in one of the most, these ungulates here in the harshest environments in the world. It's desert. Desert environments are oftentimes very rocky because you don't get soil growing on top of them. Look at what they're on now. Imagine, so you see how hooves dig in, kind of like claws. They do have to be sharp. They can't be slippery, like wearing dress shoes. Look at that. I want to repeat what that. This is what they're going to do. These are males. And the winner of these contests will be ranked as dominant, and he will have a better chance of mating than those that aren't dominant. Up he goes. Notice again how the hooves are able to grab little tiny features of the rock, like an expert rock climber. And they can tolerate. So now let's go back to the antler, the case of the hoof, the horn. So imagine you have your skull and you have a bony extension of your frontal bone going out, sticking way out, and it's heavy. Doesn't it seem like to you that it could easily break off, separate from the other bones, your frontal and parietal bone? Doesn't that seem like that could happen? Well, it probably does happen occasionally, but obviously you have here is it doesn't happen. strong enough, the bones linked together strongly enough to prevent from one thing. They don't even get concussions, which is basically your brain becoming bruised. They don't get concussions. We would get concussions, of course. So sexual selection. A male that stood aside here, so there probably are some males milling around up there that are not dominant. Those males probably have a better chance of surviving to next year if they don't engage in these battles. However, they have less of a chance of producing kids. And the currency of selection, evolution by natural selection, is the production of grandkids. They have grand copies. So we have two alternatives here. Engage in the ritual-wise dangerous battles or not engage. Which one produces more grandkids? That's all that matters in terms of what actually gets you see later generations selected for. So I hope you can see there the power of the function of antlers, horns, as well as hooves. Antlers. Antlers are actually a horn that is most of which is lost annually, which is even crazier to grow this long, heavy bone. Oh, and also the sheath as well. It costs physiologically a lot to grow that. To have the whole, and then just discard it at the end of the season. Imagine that. So these are typically found in cervids, moose, elk, deer, reindeer, and they're typically in males and not in females. They are actually the world's fastest growing bone. They are a true bone with blood flow and tissue and even hair, believe it or not. And they are the fastest growing bone. Yet another remarkable thing. So think about the deer out there right now, which are eating the acorns. Not a lot of acorns this year. I think there's going to be a big die-off of wildlife in southern New England this year because of the poor oak mast, if it really is as poor as it seems. They're out there. Much of the calories they're building up, the fat layers they're going to build up, it's going to be spent on growing, some of the males growing antlers. And you can see that nice little video here showing this just shows the growth of antler in a deer labs. This is either Michigan State or Minnesota. I'm not sure which deer. It's a deer research lab. So here you have the young male during the spring, during the time. And spring is a very tough time for ungulates because there's not much food left by March and April. So they're just down to the end on what's left to eat out in the environment, and they have to grow their gonads, hunt around. Well, not quite yet, but the point at which they grow the antler is a very physiologically difficult time of the year for them. This is the same deer just showing the sequence of growth. Fastest growing bone that is known. So it has, it's somewhat indeterminate. The way it grows is unique to the individual. And of course, the size and the point count of these are really important to a lot of people. So someone who, if you're leasing out your farmland for hunting, if you happen to have a buck that has a big rack, or even sometimes even an irregular one, you can get a lot more money for that lease than you can otherwise. And then they lose that. So when we went on our walk around outside down from Peckham Farm, right? We saw an area where they rub their antlers. We saw a tree branch where they had rubbed their antlers. So oftentimes on a walk I do around here, there's several trees that I guess the deer just continually pick on. That's the place they go rub their antlers on. And this is a rubbing the velvet, the living tissue off the antler, leaving only the dead tissue, which will be the functional tissue when they go to battle with other males. So they have to lose that. Apparently, why did he do this? I'm guessing it probably itches. Probably like scratching an itch. That's the function of the feeling needing to scratch and itch. In this case here is to scrape that velvet off. And you'll find the places, and they'll actually kill a tree sometimes, a willow or an aspen, by scraping all the cambium layer off. This is a good place if you're into hunting, for looking for places where bucks oftentimes frequent, is look for the shed. Look for the scrapes, they're called. Also, the sound of a male cervid scraping its antlers is an attractant as well to other males. You want to come and check it out, and also maybe to females as well. So sometimes people will take a rack of antlers and sort of clack them through the vegetation. They're taking the hunting class. You probably know about that. Pretty fascinating how they do that. That's one of those cycles, those circannual cycles that they have to engage in, which costs them a lot of acorns to do. So males are going to spend a lot more energy. However, females, on the other hand, have to, of course, grow an embryo, and gestate, and then lactate later on. So they don't get off easy either. Rhinos. What's up with their horns? Well, it's not a bony growth. And the craziest thing about the rhino is that this horn is nothing more than the same keratin that's in your fingernails. So if you were to grind up rhino horn into a powder, you might be able to sell it on eBay and pass it off. But it's not living tissue. No amount of analysis is going to prove definitively that that's actually rhino horn. So it's quackery medicine. This has caused the extinction or near extinction of populations of rhinos, and still to this day, from no good reason at all. It's just a tragedy. It really is a tragedy. These aren't hunted for food. They are just hunted because someone in the black market, there's this idea that rhino horn is valuable. I like pangolin scales. It's a really unfortunate thing. Anyway, functionally, they're really interesting. It's always neat to look at highly derived things like the venom producing claw of a platypus. Well, this is really highly derived in the way it grows. Here you have this. It's just really strange. It's kind of a hybrid between skin and hair. So rather than producing hair, you produce this matrix of hair-like structures that are sort of cemented together into a hardened structure. And I don't know anything about the evolution of it, but this is what it looks like. And of course, it's so. What do we do about this? Obviously, increase law enforcement, education, outreach, but it's very hard to stop the rhino poachers. They're very determined. They'll walk for many, many miles, and they'll hide in a aardvark burrow for days if they have to. So the only way they can do it really is basically have a militarized patrol in these parks, but there's been some creative things they've tried, which is, for example, creating. There's an article here on biofabricated rhino horn, and I can't remember exactly what the point of that was, whether it's to flood the market with cheap rhino horn. It's indistinguishable from the real thing, thus depressing the prices, making it less demand for it, or if it's something they actually the rhino uses itself. But I should say the other thing they do is they go in. This is not what the picture is. This is the dead one here. But they go in and cut off the horn of a rhino, so that at the very least, the poacher doesn't get to go home with anything. But you can tell that's just a terrible way to go, because it's probably not going to really. It's only going to slow down the problem and not really stop it. And finally, the giraffe horn, which is in its league of its own as well. It's called an ossicone. There's a suture here at the base, and I do not believe, well, it's not an extension of the frontal bone. That's why it's called an ossicone. So it's a separate bone. Don't know anything about how it evolved. And its function is not nearly as graphic and obvious as it is with the other antlers and horns we just saw. But it is similar. It's covered in hair, although much greater extent than a velvet covered antler. So it's just a bony extension here. Makes you wonder how much of this really has to do with just appearance. Sometimes a structure evolves and it has an appearance, and then at some point in evolutionary time, there's a disadvantage to not looking like that. And sort of it kind of gets stuck, I guess you could say. But I don't really know much about the function of the giraffe horn. So that wraps up the topic of integument.